Okay, this is SP 9.8. We're looking at, on this one, we're going to look at what chemical changes are. Okay, so the first thing we need to define is what a chemical change is. Okay, a chemical change occurs when, I'll go ahead and scoot this up because I'll tell you it's kind of a lengthy definition. One or more substances are changed into an entirely new, and yes, I want you to write new in all caps, and I also would like for you to circle it, please, because it's important that you know this, an entirely new substance, okay, with different properties, okay, and when I mean properties, we're talking about characteristics, than the beginning substance or substances. Okay? Alright. So this can happen, and what happens when this happens is you will actually get to, there's two main things about it. Okay? One, you have new chemical bonds formed. And also is that it can not, and I want you to underline not, be reversed by physical means. Okay. Now, when we learned about physical changes, we found that we could actually reverse those by some what we considered easy means of doing so, which would be like boiling water. Okay. This, however, on chemical changes, they cannot be easily reversed, okay? They cannot be done by physical means, okay? Because you have new chemical bonds that were formed, right? Now, as we go on and hopefully give you more information on this and see some examples, then we can put this definition into practicality or something that you can visually then understand. Okay, so some major things that cause chemical changes, and I think it's important that we know things that we do can cause chemical changes. If we burn something that is flammable, okay, it's getting winter. I don't know if any of y'all have wood stoves, but if you do, if you burn either wood or even if you have like a natural gas or propane or something of that sort, if you're burning something, there's actually a chemical change going on there, okay? Also, if you mix two, I'm going to put plus because it can often be more than one, but two or more reactive substances. I'm sure most of you have watched on YouTube or seen on TV or something where they mix Mentos and Diet Coke or Pepsi. I'm not sure which one it is you're supposed to use. And you see this big explosion come out of the top of the soda can, or after the Mentos have been dropped in there. Those were two substances that were reactive to each other. So when you mix two substances that are reactive, those can cause chemical changes. Another one that we sometimes forget or we don't think about is when things decompose, and when I mean decompose, things rot. Okay, let's say I catch a fish and I throw it on the creek bank, it's not a type of fish that I can eat and it's detrimental to the other fish in, let's say, the stream that I'm fishing at, and a carp or something of that sort, and I just throw it on the bank and I leave it there. If I come back in, let's say, 5 or 6 days and it's been out in the hot sun, we're going to notice that it's going to start breaking down, right? Okay, and it's rotting, it's decomposing. Okay, this is something that causes chemical changes, is when things begin to decompose or rot. Okay, another one is that when we leave metals out in the weather. Okay, if you have a bike, and I want you to put bike out beside of this, but if you leave, just to help you recall, but if you leave your bike out, let's say in the weather for 3 years in a row, eventually that bike's probably going to start to rust. Okay, so that rust is evidence that a chemical change has occurred. Okay, believe it or not, I want you also in the next bullet to write cook. When you cook, you are causing chemical change. Okay, so put cook. Another one we talked about in depth last year, which was photosynthesis. Okay, and if you remembered, we started with what? We started with sun, water and CO2, okay? And the main point of that was that we made something totally different. And that thing that we made totally different was what? We made glucose, or we made sugar for the plant, or food, okay? And we also gave off oxygen gas. Okay, but you can see how we started with two things and we ended up with two totally different things, okay? In essence, that's what a chemical change is, okay? And another one that I want you to put a bullet to include is the digestion of food. So once you eat and you've chewed it and you've swallowed, then that sets up something that will cause a chemical change, okay? That digestion of food. Okay, so now on your fun sheet, at the bottom, we want to identify evidence that a chemical change has occurred, all right? Now, the number one thing that, and you can do these in bullets, that's fine, is that you get a new substance. All right, I want you to write this in all caps. I want you to circle it, okay? It's very important that you know that when we have a chemical change, you will see a new substance, okay, that has different characteristics or properties than what you started with, okay? All right. Also, evidence is there's a color change. Okay, do you remember me talking about your bike rusting? Okay, so I want you to put bike rusting beside of this. Alright, that's an example. We left some metal out in the weather. That's what happens. Alright, another one is we can have gas that's released. Alright, and this may be through fizzing, foaming, okay, bubbles. Alright, so if you see those, more than likely you're seeing some type of chemical change, okay, because you're having a gas be released. Alright, moving on, another example is that we have a precipitant that forms, okay. Now, you probably don't know what a precipitant is, so we want to write on your fun sheet what that is. It's when a solid forms during a reaction. Okay, it's one of the neatest chemical changes you can see. You have two liquids, you mix them together, all of a sudden you see this solid clump up and form once you mix those two. Okay, this is definitely an indicator that you have a chemical reaction. Okay, alright, the next one here then we have is, I want you to write light. If you see light being given off, often we have a chemical reaction, and a good example of that one would be like fireworks, okay? Another one is releasing of energy, heat, okay? We call that exothermic, okay? And I'm going to hit enter here. Alright, so the releasing of heat energy, two things are mixed together, and you notice it gets warm, okay? If any of y'all are hunters, or let's say you go to a college football game, and your parent or whoever you're with gives you this thing that you break, a baggie, and you kind of crush the things on the inside, and it starts releasing heat, that is a chemical reaction, okay? And that's exothermic, it's giving off energy, okay? Alright. So I'm going to insert a new slide here because I ran out of room. Link after current. Okay, so continuing on. So there we talked about an exothermic reaction. You also have something when absorbing energy or heat. Okay, and we call this is called an endothermic. Okay, because the energy is being absorbed. Okay, and you're going to feel, this one is going to be cold, alright? The other one's going to be hot, this one's going to be cold. Alright. Okay, another example is a new smell. Do you remember me talking to you about the rotting fish? If you have a new smell, that is an indicator that you have a new chemical reaction. Okay, and last but not least, but chemical reactions can also cause changes in sound. Okay, it'll actually cause a sound. You'll hear something exploding. That is a chemical reaction. New bonds chemically are being made, and you're going to hear a boom. Okay, Alright, so now we have some pictures on your fun sheet. The first one here, I want you to identify from this last set of bullets. I'm going to do a few with you and you're going to do a few on your own. But this one is a marshmallow being burned, and our indicator here that there is a chemical change is that you see a color change. Okay. So you went from that nice pretty white marshmallow to the toasted marshmallow that has brown crust on the outside. Okay, now this is putting an Alka-Seltzer in water, okay, and this one is gas being released. Okay, and actually when it hits that water it has carbon dioxide in it, and it's actually giving off gas. Alright, now this one is the really cool one that I told you about. This is the precipitate. Okay. So you mixed, and you can't tell, this is the end result here, but you mixed two liquids together, and then here you got your solid. Okay. Alright, next one is fireworks, and looking back on the information that I gave you, I want you to tell me what the fireworks one is. Okay. Also, looking back on the information, if heat energy is giving off, okay, then this one, I'll tell you this one, but this one is exothermic reaction. Okay. The next one, heat energy is being absorbed and it's going to feel cold. So you have endothermic. Okay. Then this one I want you to write, this is indicating a new smell. Alright, I'm just trying to give you a visual to go along with these. And then sound, okay, is also, and I want you to tell me here at sound what it was that I talked about that gave you the information that what would cause sound. Alright, in your own words. Or you can give me an example of maybe one here on that has a picture that you see, and I talked about it being showing a chemical reaction by something else, but also this one produces sound as well. Okay, so either give me my example when I was on the front side of your sheet giving you the evidence that a chemical change has occurred, or you can look at the back and pick the other one that has another factor that's telling us that a chemical change is going on, and you have a picture of it here, but explain why that one also includes another example of why that one you could classify it two ways actually as a chemical reaction because it has sound. Okay, so this is